Hello, everybody. Welcome to the State of Ruby Tooling. As mentioned, my name is Vinny. I'm a part of the Ruby Developer Experience team. Our team created the Ruby LSP. We contribute to several aspects of gradual typing for Ruby, and we also contribute to projects like IRB, Ruby Debug, RDoc, essentially anything related to developer experience. If you want to know a little bit more about me, you can find me at Vinícius Stock on those links over there. I want to start by asking a question. Is having options a good thing? Now, it's tempting to believe that the answer to this question is always positive, and that being able to choose is going to lead to flexibility and a sense of freedom and autonomy. So it can never be a negative thing to be able to choose. But in reality, it is a little bit more complicated than that. This paper from the year 2000, When Choice is Demotivating, wanted to understand what would happen if they were to increase the complexity and the number of options related to a decision someone was making. Would they still feel like they got this sense of autonomy and freedom from being able to choose? And it turns out that's not always the case. You have a risk of inducing something called choice overload, which is essentially when the effort to make the decision has become so high that people are going to start cutting corners to make the decision. They might consider a smaller portion of the information that's available because processing everything requires too much effort. They might simplify their decision-making process, or they might try to eliminate the effort completely by just preferring whatever's the default or making no choice whatsoever. Today, I would like to talk to you about options in the context of developer experience. And where are we in the Ruby community when it comes to developer experience? I want to address one point, which is that it's common to hear people say that creating tooling for Ruby is difficult because Ruby is a dynamic language. And of course, there is truth to that. Static analysis is not as accurate in dynamic languages as we just saw Matt's talking about upstairs. But I don't think that that's the main thing holding us back today. And Ruby is not the only dynamic language in existence. JavaScript is also dynamic. Python is also dynamic. And the answer for more accurate static analysis is gradual typing. This, in the case of JavaScript, TypeScript. For Python, it was type hints. And we have our own gradual typing solutions like Sorbet and Steep. So I don't believe that today that is the main source of difficulty we face with our tooling. In my opinion, the main challenge for a modern developer experience is the level of fragmentation that we have in our tooling. Let's follow the story of a new developer. So this is a junior developer just starting out, and they want to have a complete developer experience with everything they would expect today while trying out Rust and Ruby for the very first time. The first thing they have to do is install the language. So they need to be able to install Rust and manage different Rust versions. The official way to do that is with RustUp. If they wish to write automated tests for their program, they don't have to configure anything. The test framework is built into the language, and you can just start writing your tests and executing them straight away with no setup step required. If they want to adopt formatting, they can just use Rust format, which is the official formatter for Rust maintained by the Rust team. Similarly, if they want to adopt linting, they can use Clippy, which is the official linter for the Rust language, also maintained by the Rust team. And if they want to integrate all of that into the editor and have rich features like completion and goat definition, then they can use Rust Analyzer, the official language server for Rust and also maintained by the Rust team, which integrates with all of the other default tools with zero configuration required. And if we keep taking a look at any other category of tooling for Rust, the story here is always the same. But this well-integrated experience didn't happen by accident. Rust has a dedicated developer tooling team with several different subteams that are each responsible for those individual tools. And the overarching team is responsible for designing this unified, cohesive experience, and also for coordinating the efforts of all of the subteams so that they're all building towards that same direction. What we have here is very modern default tooling, but also guidance coming from the language itself, about what your developer experience should be when you're interacting with Rust, which leads to consolidated tooling and in turn has several benefits that the Rust community gets to enjoy. Integration is easy because the teams are explicitly working towards that, making sure that they use convention over configuration, so all of the tools will integrate out of the box. It minimizes the decisions for new developers. In fact, you don't have to put in any effort in evaluating options. You can just use the set of default tools and have a great developer experience. It also minimizes the configuration you need, because you rarely ever, if at any time, need to configure something in order to make the tools work. The tools already work out of the box, and you only configure things if you want to customize behavior. You get a reduced learning curve as well, because the set of tools that you learn how to use in one Rust project is the same set of tools that you're going to be using on other Rust projects, so your knowledge transfers. And finally, you also get a very high collaboration environment. If one developer contributes a new feature to any Rust tool, then the entire community gets to benefit. When our junior developer switches to Ruby, they're going to have a very different journey. At the very first step, they're already faced with a decision. How do I install Ruby? There's no official way on how to install Ruby, so they're going to have to evaluate several different options on how they can do that. And here on the slide, we have 11 different options, some of which allow you to install Ruby, others allow you to switch your Ruby version, and a few of them allow you to do both. And in addition to that, many of these options are written as pure shell scripts, which for some of them make them shell specific and operating system specific. So in reality, only certain combinations are actually available depending on your setup. If they decide to adopt automated testing, they have another decision to make. But in this case, not because we don't have a default test framework, it's because we have two. Both Minitest and Test Unit are included as a part of your Ruby installation. So it's not possible to provide developers with a completely zero configuration testing experience. At the very minimum, you still need to add the gem to your gem file because we don't know which one of the defaults you're going to pick. If they decide to adopt typing, they have another decision to make. They can adopt gradual type checkers like Steep and Sorbet, but they also have at their disposal more novel approaches like TypeRough, which is a type profiler. And you can get varying levels of type checking with other tools as well. For formatting and linting, and here I put both in the same category because in the Ruby community, it's not so clearly separated. You also have multiple options that you can choose from and different combinations that you can make with all sorts of linters. And if you want to try to integrate all of that into the editor, then they're going to be evaluating families of language servers. You have the type checking family, which focus on features where type checking is particularly important, like completion and Goat's definition. You have the general family of language servers like Ruby LSP and SolarGraph, which try to give you the best experience possible, even if no type system is present. And then you have the formatting family of language servers that provide you with formatting. And if we continue looking at any other category of tooling for Ruby, the story here is the same. We have a lot of fragmentation at every single level. If we were to consider that our developer wants to have a full experience, so if they want tools from all of the categories that we saw, and if we limit that they can only pick one per category, which is not the case, you can combine multiple linters, multiple language servers, but for the sake of the argument, let's say they can only pick one, and keeping in mind that the lists are not exhaustive. There are many tools that are not on those lists, but there are entire categories of tools missing, like debugging, which I didn't put up. With these constraints, Rust has one possible combination of how you can configure your environment, the set of default tools. And Ruby has the very conservative number of 11,000 ways which you can configure your environment. If we were to visualize that, Rust's visualization would be a straight line where on each level you just pick the next default tool. And for Ruby, you can't quite put that on a slide because there are simply way too many combinations to visualize. It's no wonder that it's extremely difficult to guarantee that integrations are going to work properly for every possible combination of way that you can configure your environment. If we take a look at different projects that all use different sets of tools, you also conclude that learning Ruby itself is not enough to be able to contribute to all of those. For example, if you contribute to project A and you're not used to gradual typing, but then you have to work on project B, then you're going to have to learn the specifics of STEEP and RBS in order to be able to make a successful contribution. But if you then want to contribute to open source project C, now you need to learn the specifics of another gradual typing system, Sorbet, in order to be able to contribute. And this is not exclusive to type checkers. It's the same thing for test frameworks, linters, or even debuggers. If they use a different debugger, you're going to have to learn how to use it to debug your code. The essence here is that the set of tools you learn how to use in one project may not fully transfer to other Ruby projects. What we have here is missing defaults, but also guidance from the language. Ruby is not prescriptive about what your developer experience should be. And that, in practice, is delegating the design of the overall developer experience to the community, which leads to fragmentation. And in turn, we see all of the opposites of what the Rust community enjoys. Integration is extremely difficult because we have several implementations of the same tools, all of which don't conform to any standardized API, so you need custom integration for all of those tools. You get an excessive number of decisions for new developers. Can we really expect that a junior developer who's just starting out is going to understand all of the trade-offs they're making by picking tools from all of those categories? Because integration is difficult, it also increases the amount of configuration required, because the easy way out is to ask users for more and more configuration so that they are responsible for ensuring that the tools are going to integrate properly. So it degrades our ability to provide a nice out-of-the-box experience. It increases the learning curve because the set of tools you learn how to use in one project will not necessarily transfer to other Ruby projects. You may need to relearn the same tools you already knew, but just a different implementation. And it spreads the efforts of our community. If we take a look at JavaScript, which is another highly fragmented ecosystem, they have similar issues. They have dependency management, fragmentation, runtime fragmentation. In that sense, they're very similar to the Ruby ecosystem. But they do have an advantage. They have a much larger community. If we take a look at the most recent Stack Overflow results, the number of respondents for JavaScript was at 62%. It was the #1 programming language. And Ruby was just a little over 5%. So maybe JavaScript has enough people in their community that they can afford to have all of this richness and diversity in tooling. They can sustain all of these different options. But I want to argue that a community our size cannot afford to divide our efforts maintaining several different implementations of the same highly complex tools. As another statistic, if we take a look at the number of non-unique contributors for language servers, as of the time when I wrote this slide, Rust Analyzer had 874 contributors. And if we sum up the number of 5 actively maintained language servers in our community, Sorbet, Steep, SolarGraph, Ruby LSP, and TypeProf, and this is non-unique, so Dependabot is being counted 5 times. And I'm being counted more than once too. It's an inflated number. And even though it's inflated, we're not even close to the number of contributors that Rust Analyzer has, which is a lot more impactful to the quality of our tools than the fact that Ruby is a dynamic language. And I want to say that building new tools might make sense. I am not arguing that we should stop making new tools. The point that I'm trying to make is that you don't automatically get a better developer experience simply by creating more tools, not without considering how they're going to fit into this general picture of developer experience, how they're going to integrate with the rest of the ecosystem. Because developer experience is not about the tools in isolation, it's about how they combine to allow you to interact with the language. If we go back to the article that we were discussing at the very beginning, what we want to avoid is being in the last option of making no choice whatsoever. That would mean that evaluating all of the different options requires so much effort that in the best possible case, the developer might be neglecting an entire category of tooling by choice. And in the worst possible case, they might decide to not try out Ruby and go try some other language that is easier to get started. We want to be where Rust is, where the default option is so good that they can just use the defaults and have a great developer experience without investing anything in the decision. After all, using the tools is not the developer's final goal. The developer doesn't have its final goal to use Rails or to use the Ruby LSP or to use Sorbet. Those are just stepping stones, and the goal is to build something. So setting up your development environment should be absolutely effortless, and it should set you up for success so that you can focus on what it is that you're trying to build. And perception matters, right? The way that Ruby is perceived is important for us. If you search online, there's a lot of research into how certain elements of one thing can impact the perception of that thing overall. Like certain elements of brands can impact how consumers feel about their products, or how certain aspects of a location can impact tourism, or how certain elements of a restaurant can impact how people feel about the food. This effect is called the halo effect. It is when one trait impacts the overall perception of that thing. I do not believe that Ruby is immune to this effect. I don't think that Ruby, the language, is evaluated independently from its developer experience. So a new developer wouldn't know where the language ends and the tooling starts, or who maintains what. So the developer experience is important for a new developer to evaluate how they feel about Ruby and what their first contact with the language is, how they feel about that. The question I want to raise, and the concern that I have, is could we be losing developers who are genuinely interested in Ruby because getting started may be a little bit more difficult than it is in other languages today? Let's take a look at another situation. If we take a look at Windows, setting up a modern development environment on Windows is a little bit more difficult than it is on macOS and Linux. And the reason for that is that many of the tools that we use don't support Windows. In particular, many of the version managers don't support Windows. Sorbet doesn't support Windows, but also core methods of the Ruby API are sometimes not implemented for Windows. Let's take a look at some more statistics. In the latest Stack Overflow survey, professional usage of Windows was at 47%. And the numbers here don't add up to 100 because you could select all of the operating systems that you worked with. JetBrains, which is a company that makes developer tooling and commercial IDEs, they're very good. If you don't know them, check them out. They have their own survey called the State of the Developer Ecosystem. And in their survey, Windows usage was even higher at 64%. The Rust community survey reported Windows in the third place, but still with a healthy number of developers, about 32%, which is roughly about a third of the community. It's a decent number. And the Ruby on Rails community survey reported about 4% of Rubyists using Windows. And this number is not actually just Windows. It includes WSL, which is the Linux subsystem. So the number of people using just Windows purely is even smaller than that. I think that when we see a number this discrepant from the rest of the programming community, we have to ask ourselves what is happening exactly here. If the answer is that Rubyists just have a predisposition to using macOS, then maybe there's no problem. But the question I want to raise is, could we be losing developers who are genuinely interested in our community and maybe have a hard time getting started? What can the future look like for our tooling? I want to be super fair here and mention that Rust case is the absolute exception. If we take a look at many other popular programming languages like Python, JavaScript, PHP, most of them are also fragmented and don't have this official cohesive story of developer experience. In fact, the only other language that I found to have a somewhat similar experience as Rust is Go, which also has official tooling that's quite solid. And there's a relationship here between these lists. The fragmented languages are all much, much older than Go and Rust are, which makes perfect sense. Many of the techniques that we use today didn't exist back when Ruby and Python were created, so it's only natural that the ecosystem of tooling evolved organically and we landed up in a place with more fragmentation, whereas Rust and Go had the opportunity to plan the path ahead from the very beginning, and were able to create this compelling story for developer experience. But there's nothing stopping us from learning from all of the success that Rust has had and bringing that learning to our community. And in fact, there are other programming languages that are catching up to this. Elixir recently announced their official language server team, which is going to build rich integrations for the editor for the Elixir language. And in the Python land, the problem of having modern, integrated by default, highly performant tooling was deemed so valuable that there is a company behind it. Astro is a company for which the mission is to create the full suite of next generation of Python tooling. Our tooling is also becoming more integrated, but I do think that there's still a ton of work to be done if we want to match what we're seeing in those communities, especially in Rust. However, I do also believe that we can have a more integrated experience even today. And the answer for me comes from outside of our community. It comes from the language server protocol. Language servers are uniquely tailored to integrate and aggregate with other tools. For example, they can integrate with your test framework, your linter, your type checker, your formatter. But today in our community, we are seeing language server fragmentation. And that, of course, has consequences for the developer experience as well. If we take a look at editors, many of them have some sort of extension hosts, like a separate process, that will execute the code in your extensions and is normally shared across all of them. If you have multiple language servers connected, in addition to having to configure each one of them and ensuring that they don't step on each other's toes, they're all going to do duplicate work to index your code base, figure out what is available, and then maintain an in-memory representation of your entire code base, which could be several gigabytes in memory, depending on how large of a project you're working on. And then for every single operation you do in the editor, like opening documents, those operations are also going to be replicated for each language server, which are also going to maintain duplicate representations of all of the documents you're interacting with. It's a lot of duplicate work for maintainers who end up having to solve the same problems over and over again. But it's also increased memory usage, and under certain conditions, one language server could potentially make the other ones slower. If we could consolidate language servers, I think we could do a better job at delivering a more integrated, out-of-the-box experience for Ruby. And of course, I am incredibly biased, but the Ruby LSP may help here. We've been experimenting for a long time now with what we're calling Ruby LSP add-ons. And this is a way for other gems to deliver integrations for the editor through the Ruby LSP. It's essentially an API layer for the language server so that other gems can enhance the features that we provide. If one of your dependencies in your project exports an add-on, it will be automatically detected and loaded so that your experience gets more tailored to the project that you're working on. For example, Standard, the linter and formatter, recently shipped with an add-on inside the gem. If you have Standard in your gem file, the Ruby LSP will automatically pick that up and integrate with it for linting. And alternatively, add-ons can also be distributed as an independent gem, which we also have some examples of those. There is no need to write a VS Code extension or editor plugin with this approach. There's no need to write a brand new language server and decide how you're going to represent documents or how you're going to handle different encodings coming from the editor. And there is no need to write your own toolkit of static analysis tools to be able to understand Ruby code. All of that is provided by the add-on API. In this scenario, the Ruby LSP is a little bit more than just a language server, but also a platform for editor integrations. And through the add-on API, we can make the experience richer based on what type of project the user is currently working on. We already have the Rails add-on, which adds Rails-specific features to the Ruby LSP. We have the RSpec add-on adding support for RSpec tests. As I mentioned, we also have the Standard add-on, which adds linting and formatting for Standard if you're using that. But we can have add-ons for any kind of tool or framework that could benefit from providing their users with a richer editor experience. And because everything's going through the language server, and the language server connects to any editor that supports the protocol, then everything that gets contributed by add-ons is also available to any editor. It doesn't have to be VS Code specific. And in the age of artificial intelligence, if your editor has an LLM, and if it provides an API that the Ruby LSP could use to provide extra information to the LLM, then we could make it so that the Ruby LSP will provide extra information and extra context based on what you're currently editing, but also based on everything that was contributed by add-ons. This doesn't exist at the moment. These APIs are not available, but I'm hoping they will be available soon. I think developer experience for Ruby can be a lot more than just good. In fact, I believe that we can lead the way when it comes to developer experience in highly dynamic languages, even when there's no type system present. And to me, there are two important things for us to get there. Number one is considering a unified vision for developer experience. To achieve the level of sophistication that we're seeing in the Rust community, we need to be able to have the tools integrate automatically and have the tools create APIs to talk to each other. Building the tools in isolation will not cut it. And so to get there, we also need to coordinate our efforts, join forces, and ensure that Ruby has a great developer experience. Thank you very much.